CloudVision Universal Network Observability has now extended its support to include comprehensive AI jobs visibility for your AI workloads. Within CloudVision, you now have access to unified views for networking as well as for your GPU servers and AI jobs. These include metrics such as job completion times, congestion indicators like packet drops, queue utilization thresholds, PFC post frames, and ECN mark packets. These can be quite useful when conducting performance analysis of your AI jobs. You can also access AI job detail analytics and dive deep into individual job level metrics. This will help you uncover crucial AI job specific insights, including end-to-end flow visualization of your AI workload flows that traverse through the network. Let's take a look at how Arista CloudVision provides detailed analytics and visibility into your AI networking infrastructure. In our current topology, we are running a training job on 64 servers, each equipped with 8 NVIDIA GPUs. These servers are interconnected through an Arista leaf-spine network architecture. Let's take a look at a detailed end-to-end example to see how we can identify potential issues related to one of the AI jobs. Here, we are scheduling a job from the Slurm Workload Manager. Slurm is an open-source, highly scalable cluster management and job scheduling system. As you see, as soon as the job starts, CloudVision picks up the details from this job and updates the AI jobs dashboard. From now on, we can keep track of this particular job that is running, and CloudVision will show all the networking and GPU server related information. We will let this job run for its duration and come back here after it finishes. While the job is running, you can take a look at various metrics about your network's health using our network health dashboard. Here, you can see detailed information about various network events that are happening currently. Using this timeline visual breakdown of per device view helps you to very quickly spot any critical events that are happening during specific times. When we completed the job we started, we noticed it took longer to finish than the previous job iteration. Let's try to identify the root cause of this increase in job completion time. Let's navigate towards the job details dashboard for this particular job. As we see, there are no apparent critical issues under the server-side events. However, we see CloudVision highlighting critical events under the network overview section. We see an ECN marked packet breach threshold event here. If we click on the leaf switches, we see the leaf 3 switch in our topology generates these explicit congestion notification events. This ECN event might be pinpointed to a potential issue for this increase in job completion time. Let's dig deep to narrow down the root cause. Let's click on this ECN event to take a detailed look. As you can see, we are seeing a lot more specific information, including rates and counters about this ECN event here. However, we still cannot exactly pinpoint the root cause of this particular event. In a situation like this, we can get help from CloudVision's inference capabilities to figure out any related issues that happen during this time period. Let's click on the Related Events tab here. There seems to be a queue drops breach threshold event on the same device during this time period. Clicking on this event leads to the queue usage metrics of this switch. All these metrics are now enhanced to provide counters at intervals of microseconds using EOS's AI Analyzer and Latency Analyzer features. At this point, we know that due to some reason, queue usage unexpectedly increased during this particular job execution. However, we still need to figure out the exact reason for this usage increase. Now that we know the exact device that caused all these issues, let's go back to the job details page to see all the traffic flows for this job that traverse through this particular leaf switch. Let's filter this list by device leaf 3. Here, we see 3 specific flows through this device that were part of this specific training job. Clicking on a flow will give you a quick snapshot view. We can click on the View in Topology button to take us to the detailed topology. Here's the detailed full topology view of this particular training job. Here, we can go back and overlay full flow views of our entire network. Let's click on the Flows button on the left-hand side of the screen to access the entire flow view. Let's look into the flows that are traversing through this Leaf 3 switch link. Here we see that in addition to the 3 flows that were initially part of our training job, another flow is utilizing the same links. This flow happens to belong to another one of our training jobs. At this point, we can confirm that the flows of this particular AI job got mixed with flows from another job, and that resulted in queue drops. This is a common problem we've seen in our customer deployments. AI clusters usually have low entropy of large bandwidth flows. Traditional load balancing is flow-based, so the distribution of flows becomes suboptimal with AI workloads, leading to congestion issues. The newly introduced cluster load balancing for AI workloads in EOS can help in situations like these to ensure balanced utilization and consistent low latency. As you can see, CloudVision's universal network observability helps network administrators gain in-depth visibility and identify the root cause of potential issues in AI networking infrastructures. Thanks for watching.